welcome to the September version of the Liftoff webinar featuring OmnicoAGV, talking about advanced metal and composite hybrid lightweight tooling systems. I appreciate everyone taking the time to join us today. This is Joe Steele from Lift. I had a couple of housekeeping items I'd like to go over with you. The first is please again put your phones on mute. The less background noise we have, the better for the presenters. Second of all, if you have any questions, please use the chat function that's part of the GoToMeeting taskbar that you have on the right side of your screen, and send the question to the organizer. That question will then come to me, and I will help facilitate any Q&A end of the presentation today. Finally, each of our Liftoff webinars are being recorded. So this is being recorded and will be posted on the website for future viewing. So if you've missed any of our previous Liftoff webinars, you can go back and check them out there. They are on the lift.technology website, and under the technology tab, you can visit all of the Liftoff webinars from the past and see who is coming up in the future. A few things to talk about Lift. For those who don't know, we are a member of the Manufacturing USA Network. The Manufacturing USA Network is a group of public-private partnerships, institutions around the country. We are based here in Detroit, Michigan. Each of the Manufacturing USA Networks have a specific technology that they focus on to do their R&D work, as well as their workforce education development work. And our focus of technology here at Lift is lightweight metals. Our mission is a broad one, but it is simply stated, we are revolutionizing lightweight metals manufacturing through innovation and education. And we do that in three ways, really. We do that through the technology development that I mentioned, the R&D work that we have going on with our technology portfolio. You can visit some more of those programs and learn more about those projects at lift.technology. We also focus on technology transition, which is to say, what good is developing these new innovations without helping shepherd them into the marketplace? So we really work towards technology transition as part of that mission as well. Finally, education and workforce development. Along with the R&D work and the transition of technology into the marketplace, we want to make sure that there are people that have the skills, knowledge, and abilities to work with these new innovations when they get into the marketplace. So from engineers to technicians on the shop floor, we want to make sure that there are talented people in the world of manufacturing to support both the U.S. and defense manufacturing bases. Again, more information, you can visit us at lift.technology. You can give us a call at the phone number on the screen, or you can follow us on our social channels at news from. Here at our facility in Detroit, we share some space with IACME, one of the other institutes that focuses on composite materials, which is apropos for our conversation today. We have a 100,000 square foot facility here in Detroit, and you can see on your screen some of the equipment that we have available for your use and your R&D use. You can give us a call and schedule a tour or schedule some time on any of those machines. We'd be happy to show it to you. We also have many services that we are able to provide. So we are looking forward to anyone wanting to give us a call, want to come walk through the facility. If you're local, that's fantastic. We have pretty much an open door policy. If you are somewhere else around the country, we do have a virtual tour that's available on our website, so you can click through and kind of walk through our high bay there. But again, visit the website, give us a call. We'd be happy to work with you on that. I mentioned the Liftoff webinar series is brought to you both by Lift and the Michigan Manufacturing Technology Center. MMTC, or the center, has been a partner of Lift since our very formation back in 2014. And to talk a little bit about what services the center provides, Elliot Forsyth is on the line to share a little bit about the center and what they do. Elliot?
Hi, Joe. Thank you very much. And good afternoon, everyone. Thank you for joining what we believe will be a very informative seminar, as have been all of those throughout the past year plus of doing these seminar events. As Joe mentioned, Lift is part of 14 national networks designed to provide leading innovation in terms of specific applications to manufacturing across the United States. It's comprised of terrific academic and corporate partners and leading experts in the field. At the Michigan Manufacturing Technology Center, we too are all about manufacturing. We take a more applied approach where we work with companies every single day to improve their operations, for them to fundamentally continue to prosper and thrive, and to help our nation grow. As you can see on the screen here, we offer a variety of services, from operational excellence to find ways for companies to grow, to increase their skill development. We do technology acceleration, and we also are able to look at the marketplace and to help companies determine new markets to enter or how to work more effectively in the competitive marketplace. Joe, do we have another slide? Nope. Okay. So as Joe mentioned, we've been working in partnership with LIFT. Our mission in connection with LIFT is, once the new technology and applications are developed through projects at LIFT, our responsibility is to work with manufacturers across the United States to help implement those best practices in their operations. So enjoy this webinar, and I'll turn it back to Joe.
Thank you very much, Elliot. So today, without further ado, you've heard a little bit about LIFT, you've heard a little bit about the center. I want to introduce a couple people to you that will be presenting today. The first is John Keogh, a development engineer with us here at LIFT. He will be joining our main speaker today to talk on behalf of OmnicoAGV. We'll also be joined by Greg Peterson. Speaking of the center and LIFT have a shared asset, I guess, if you will, with Greg on the engineering side here. He works with both LIFT and through the center, and is here at LIFT really helping us engage with small and medium-sized manufacturers, which is really how this webinar series came to be. And finally, our main presenter is Jerry Van Ness, the founder and chief visionary officer of OmnicoAGV. He began his first business back in 1970. Since then, he's gotten into tooling and R&D and manufacturing. His present companies are involved in the designing and building of automation equipment with a focus on the use of engineered, commercial off-the-shelf modular components. His focus now is on disrupting the one-size-fits-all approach for an AGV, fixed frame chassis, which is inherently inflexible for modifications of shape, size, and payload capacity. The one-size-fits-all approach supports higher volume, which reduces manufacturing costs for singular purpose equipment, but this is at the expense of flexibility for change. In general, Jerry's business is focused on the reduction of the cost for change. So without further ado, Jerry, I'll hand it off to you.
Thank you, Ned. Good afternoon. So my name is Jerry Van Ness. I'm with OmnicoAGV. I'm a member of both LIFT and OmnicoAGV. I've been in the automation tooling business for over 20 years. On this webinar, I would like to focus on transfer of extreme large size automotive and aerospace panels, plus construction of AGVs, which is automated guided vehicles, with a focus on space frame construction that is easy to modify for both shape, size, and capacity. I will show why our hybrid metal and composite tooling system, supported by both LIFT and OmnicoAGV, provides higher throughput than current tooling systems. Our product is called L&J Extreme G-Force Collection. It features interlocking blocks, or I-blocks that we call them, to construct tooling. These are a few of the customers we have been doing business with. FCA at the bottom, Fiat Chrysler Automotive, World Class Manufacturing Academy. We have built an AGV's assembly line that you'll see on the next slide. Our tooling system has been in manufacturing plants for over 20 years. At Fiat Chrysler, World-Class Manufacturing Academy, flip the next one. We built an AGV assembly line that is all modular construction from standard components. No welding. Advantages are reduced build times using off-the-shelf components. Modular components allow for ease of assembly and adjustment. Ability to reconfigure. The main appeal of a modular system is flexibility that extends over the life of a structure. Being able to easily move things around and make small changes while the structure remains in place can be invaluable, allowing for optimization and assembly process over the life of a program. This video is similar to the unit AGV at Chrysler World-Class Manufacturing Academy. The video shows employees can we go back to the other side video? Just go to this video. The video shows Fiat Chrysler Academy Employee Training Center. The AGV assembly line is the main focus of the academy. Each assembly transport vehicle has a lift platform that can be adjustable to the work height to match the process. The moving line teaches the entire assembly process of a vehicle. The last stage is removing the completed vehicle. The vehicles are later put back on the moving AGV for disassembly. This process is repeated many times during the day. Now if we can flip back to the next one. This video shows the marriage of an engine and transmission. This is for a moving assembly process. The transport vehicle built by L&J includes all tooling, is similar to the ones at Fiat Chrysler's Academy. An all modular build that includes a lift platform to get correct work height. The lift platform is used when there is a transfer from the AGV to a moving overhead transfer line. Both AGV and transfer lines are moving at the same speed. The omnidirectional vehicle construction process is the same as the last two AGVs, all modular. AGV has a lift platform to achieve the proper working height. You can run the video. This AGV is designed to also be a mobile work platform that the vehicle assembler works off of. All the vehicle build components can be kitted and on the AGV for assembly. The AGV design allows for an assembler to walk on and off the moving AGV. There can be two assemblers on each side of the AGV. The omnidirectional AGV can move in any direction, also rotate at the same time. The video shows the AGV moving at a location, stopping, then rotating. The AGV moving to location can rotate during its first travel and be pointed in the right direction when it arrives to follow the planned path. These vehicles can adjust from planned path when they find an obstruction in their way. Go around the object and get back on the planned path. This is what you see now. Moving around something in the way, which is the same vehicle that we're moving around as at the Chrysler World-Class Manufacturing Academy, doing the same project. So the operation can be more automated, where you can work on the platform, a moving platform, than walking alongside it. L&J eye blocks, interchangeable blocks, are Lego-like and can be used to build anything you can imagine. All robots require end-of-arm tooling. Tooling can be welded, steel construction, or modular construction. L&J is focused on extreme large-size tooling, where a welded steel construction tool weight will be too heavy for a robot, and the deflection from the tool's own weight will limit its performance. Our main focus is on hybrid eye block connections and carbon fiber open architecture tooling.
So this is John Keogh here. I'm the development engineer from LIFT, as Joe had mentioned earlier, and I'm going to be telling you about LIFT's involvement with this project here really quick on this slide. So these eye blocks are engineered to utilize an extrusion process, so extruded aluminum, and this is an inherently low-cost process, creating a near-net shape. Excuse me. So if you look on the right side there, you can see a view of our high bay in LIFT, and that closed-in area right closest to us is our extrusion table. It has our extrusion press, sorry. It has a 400-inch run length. Now, given that we have this common eye block architecture and the near net shape that comes from extrusion, you can see really that borne out in the two panels there on the bottom right. So the left and right panels there on the bottom represent 3D printed images, actually, 3D printed pieces, cross sections of these nodes. And depending upon the post-extrusion manufacturing methods, you can use these nodes to be applied in a variety of different methods. So on the bottom right there, you can see that that's being used to generate a 90-degree angle, and with the expanded architecture, open architecture, carbon fiber tubing. You can also change the angle, though, throughout a wide range. Now, it's important to note as well that with this type of an approach and this type of system, it affords a rapid build for whatever space frame structure you're trying to make, and it also only requires low-cost tooling. Moreover, the hardware itself is easily configurable, and if you have, say, an already assembled space frame structure, it's easy to change components without having to disassemble or affect the remaining structure. And once again, just to note, one of the interesting aspects of this system, and also that which ties us together with IACME, is the open architecture carbon fiber tubing. That tubing is quite impressive when you hold it in your hands, actually. It's incredibly rigid and it's incredibly lightweight. So with that said, we're going to move to the next slide, and I'll hand it back to Jerry here.
So our energy-absorbing elastic liner, which shows there in green, it isolates in characteristics that decouple impulse shock from traveling through the structure. And that's one of our high focus points, is that liner. The liner has locks that won't allow it to rotate in the eye block. The liner can be adhesively bonded to the tube. The liner is designed to break the adhesive bond when required. So there's a lot of problem with tube slippage, and you can use adhesives to bond the liner to the tube after everything's set in place. And then if you need to change for an adjustment or something, you can use the liner can be peeled back, so you can use a peel force to break the bond. The liner can have different ID shapes. It can have an octagon shape to use the Keogh's bodybuilder system, and any other shape you want to design.
All right, the advantages of the eye block are basically that they're very easy to adjust in terms of any shape that you want, any size payload that you need. The energy-absorbing elastic liner basically distributes the load uniformly and eliminates point loading, and that can have a pretty big effect when you've got these very large, long arms that can approach 30 feet or even go beyond that, as Jerry will talk in the next few minutes. And by doing that, you basically are minimizing the shock loads that go into the structure, as well as minimizing the torque that's acting on the connection points. The non-slip adjustable reconfigurable space frame tube connections give you a tremendous amount of flexibility, not only in being able to build the machine initially, but they also allow the machine to be reconfigured very easily. And Jerry will talk about this in the next few slides here, but basically you can train people very quickly to be able to configure the space frame, put it together, get it working, and then a year or two down the road, as you change products, you can very easily change over to make this work, use the same components, carry them over, and use them for the next platforms that you are putting into production. The low clamping force is very key. This is all directed at minimizing the input loads to the structure. With welded structures, you typically create heat-affected zones that lower the material strength. What Jerry has done with this system is basically eliminated heat-affected zones, which means you essentially increase apparent material strength, and you've also reduced the potential for for fatigue issues.
I'll take this one.
Okay.
So, the return on investment increases as the tool length increases in size. Open architecture tubing is damage tolerant. It can take a high clamping strain plus transfer load strain. It is a rope braided structure where one rope breaking does not affect the other ropes. So this tube, you can get extreme long lengths. It doesn't have the weight effect that the steel has. You can increase the section height that changes the stiffness and load carrying capacity. And then the next slide is, Greg will respond to the next two slides.
All right. Basically, what we're talking about here is the return on investment as the product gets larger in size. This open architecture carbon fiber construction, the braided tubing, allows for much longer structures by essentially being very, very light as opposed to steel structures that are traditionally used. And what that means is as you get longer and longer, you got more and more torque acting on the connection points, which can cause long-term fatigue. There's a lower cost associated with this by increasing the section height. And when you increase the section height, you're essentially utilizing base times the height cubed divided by the shape factor physics. And what that means is if you double the height, you can essentially increase the section inertia by a factor of 8. So that's a very key part of this. You can do this very, very easily and a minimal weight to achieve these increases in section height with the OmnicoAGV construction. And this reduced torque acting on connections is always a very, very positive thing to do. And this basically minimizes any sort of durability concerns, especially combined with the elastomeric construction that gives you a lot of flexibility. Gary will talk about that in the next few slides here. The low mass of this end defect basically allows you to build smaller robots because the critical support structure is now smaller, is now lighter, can be much longer. The 10% of the weight of a steel arm is very significant, giving you the potential to make these units very small in terms of the robotics, which reduces the cost. But not only that, as you get the smaller robots, you need less energy to drive those. So that basically contributes to long-term cost savings through reduced energy costs as a result of the smaller robots. The reduced cycle time to get to higher speeds gives you more opportunity to do more. That's another key factor here, that these lighter weight units have much less inertia than the steel units. They can contribute to increased throughput as a result of the reduced cycle times per unit job. The next slide here is basically the assembly. This is very key. No welding, which means you don't need skilled labor to put this together. Jerry estimates that you can train employees in 4 hours to be able to be an expert at assembly. It's bolted construction. There's no skilled labor required to construct it. You have plans that basically tell you the geometry, and with very little supervision, employees can put this together relatively quickly. There's no welding required, so that means that the labor cost is greatly reduced. If you've looked at labor costs or tried to get something welded recently, you'll find if you can find a welder, they're very, very expensive. And LIFT is helping train people in these technical areas to help support companies like Jerry. The self-fixturing design minimizes things like the requirement of needing a jig fixture to put this together. You basically cut these parts to length and it's self-jigging. I've talked about no heat affected zone repeatedly. It's just a very, very key part of Jerry's overview in putting this machine together. And these individual component changes can take place without affecting the remaining frame. So you don't have to cut a welded part apart to change the geometry of this machine. You can do it very easily by simply unbolting local components and inserting longer, shorter length parts.
So Boeing's impact on factory future, breaking the paradigm of a fixed workspace and fixed tooling. Customized geometry allows for decades of use. So we have, on our standard components, we've had it out for 20 years, and all these new I-blocks will adapt and connect to the same thing. And we plan on having new versions, just like Legos. Just keep designing new products for different components that will all work and attach and last forever. The long-term viability creates economical advantages. There's no obsolescence, changing plant layouts. I-block modular interlocking components replace fixed geometry welded structures that do not allow for easy, rapid configuration change. And that's always been a problem with welded structures. You have to weld them, you have to stress relieve them. It's difficult to change. Then you go back and weld on them. Then you have stress again and major problems. And with new metrology systems, you can place anything on a tool, and then you can calibrate location, and you can shim it to location, so you can have high precision with a structure that you can just build like Legos, and you get the same precision out of it. Okay. So Boeing has just didn't say the 777X, but they have a new 777X wing. That's all composites, 110 foot long, it's carbon fiber. And so there are some large AGVs that are built to move the 110 foot long wing. And a lot of these AGVs, you can use them also for an assembly fixture. So if you're building an assembly fixture that's mobile and movable, and you want one for 110 foot long, same length of the wing, and you made it out of steel, and you have a composite wing, it doesn't match the thermal expansion of the composite wing. So with these I-blocks, you can use carbon fiber tubes to create the full length fixture. You just stagger the tubes, you can have holes in them and stuff for snap-on components, and you can have a full length fixture that matches the thermal expansion of the carbon fiber composite wing. And for an all aluminum wing, you can use the same I-block with aluminum tubing to have the same thermal expansion. So a 110 foot long steel welded fixture will not, it's too long and too wide to transport. So you'd have to build something with steel on site. If you have a modular fixture, you can build it on site with your regular workforce and match the same thermal expansion to whatever you're building. The advantages for aerospace is open space manufacturing, no fixed equipment, which allows machines to move around and do work. They're easy to upgrade, modify, reconfigure. Modular components allow for change while the structure remains in place, and this is a real big benefit. It allows for assembly process to be optimized over the life of the program, which means that you can continually upgrade it, constant improvements. We have developed a concept AGV, which you'll see in a couple slides, that you'll see shortly, that can drive over a wind blade and do manufacturing operations over its entire length. The current manufacturing process is not automated, and factories are not close to the wind field, making transportation difficult and costly. So the intelligent AGV can assist in field assembly of large components, such as wind turbine blades, using sensors and fine motor control, retain high accurate positioning along the entire length of the component. Do it on site. Then, when you're going to another site, the mobile infrastructure allows for either transferring equipment, auxiliary equipment to be easily added or removed to maximize efficiency. So the system really needs to be automated because it's Blackstone manufacturing now. Next. Wind advantages. AGVs can be transported in sections to a job site and assemble. It is easy to disassemble and transfer to another job site. Assembly process needs to be automated to build blades on site, and AGVs can provide those functions. This is where I was talking about the next generation AGV. So this is a concept. This AGV can drive over a Boeing 777X wing, wind blade, and we have some other versions of them that have a smaller footprint where it's a 3-column, single arm, and the wheels can float, so it's great for agriculture. So you can have a vehicle that can drive over a farmer field. It can do maybe 20 rows at a time, or you can pick them all 20 rows. Lightweight, you have a problem with soil compaction in fields and irregularity of the thing, so you need an extreme lightweight structure, and you can use motion tracking to find things you want to pick. If you want picking pumpkins or other things, you can automatically track those things. You can have a storage bin on these vehicles. They can drive down one road, rotate, go down another road. So there's a lot of advantages. So this machine is multitasking, and it can perform normally dissimilar operations in one location. And so there's 3 separate arms there. The arms have to be, the other structures could be welded steel or other things, but the arms have to be a carbon fiber structure that is, they're 20-foot long. And when they're that long and you have high acceleration of mass moving, you need something lightweight that can move fast, that dampens quickly, high stiffness. And if you see some of these machines that are, picking up candy and something, putting it in boxes that move in seconds faster than you get your eyes in you, this machine is basically the same similar design that can do those things. Only arms, when the arms get 20-foot long and you have movement, there's lots of problems. They have to be extreme low mass, high stiffness, and that's what a carbon fiber structure can do. And then what we're marketing is the clamping system, being the eye blocks with the elastic liner. That's the main connection that allows all these things to be connected together, and if you snap the tube or something, it's easily replaced. So the three moving arms can each perform different operations while the AGV is stationary moving. High-speed motion tracking system can sync the machine to the workpiece, allowing for manufacturing operations while the AGV is in motion. So a lot of things moving, you can have a motion capture system that picks points along your workpiece, whatever you're working on, and it can be moving and doing its function. So you have a defined program path, what you're going to do, that tracks with the part, and you can adjust for, you know, deflection and other things as you're moving. And with three separate arms, you can be doing three different functions. So one function, you could be doing a machine operation, the next arm could be doing a fine polishing or finishing, and the next arm could be doing a spray coating. So it could be doing three dissimilar functions all at the same time. So this is a real paradigm shift in manufacturing and space frame design, and all the control systems are all available. All they need is a customer. So there is a problem area out there that needs to be addressed, and these machines can address it. I think, so I thank you for your time. Please contact me with any questions.
Thank you very much, Jerry and Greg and John. Again, if you have questions for the group today, please let us know. Use the chat function that's on the GoToMeeting taskbar that you have. For me, it's on the right-hand side of my screen there. But we do have some questions that came in, and I'll just address these to the panel because I'm not sure exactly who they might be addressed to. But can the isolator increase tool life by reducing the shock or impulse?
Yes. So it isolates the transfer through the whole system. So if you have the elastic line, it decouples the kinetic energy, and so if you're machining and with a long arm and you hit different loading that wasn't programmed for, and then all that load goes back in there, it helps share the load with all the other connections. There's just lots of tube connections on there, and it softens that energy. So it takes high load off the tool, the pressure.
All right. Do you expect longer life with the carbon fiber or aluminum arms? Do you expect that longer life for the arms, or do you expect that longer life for robots?
Well, so aluminum starts fatigue at cycle 1. So aluminum doesn't have a life cycle. Steel does. But carbon fiber has a long, it's basically fatigue resistant. So either it's broke or it's not broke. So the advantage is you can run high speeds. Big advantage is it dampens quickly, and it's low mass. So whatever you're doing, you can extend out, 20, 30 foot to do things, and it dampens quicker. And then you just change the section height, especially with the open architecture tubing. You can change the section height without adding a lot of material, so the cost goes way down by just changing the section height, and you get extreme high stiffness. That might answer it.
No problem. Thank you very much. Again, if you have questions, please use the chat function on the side of your screen there. Again, Jerry's contact information is on your screen, so feel free to follow up with him afterwards as well. Can you describe the advantages of a lightweight AGV train versus current technology, if you really just drill down on a couple of advantages there?
Well, lightweight is, So most of these AGVs are battery operated, and so when you're moving a lot of weight, it takes a lot more energy to move that structure. And if you do have a structure that, say, was 110 foot long, and then you have multiple AGVs you can connect together, and you have to read the strain on the whole length of the vehicle, so as it's moving, and so moving something lighter is easier than something rigid. It takes more inertia to move it. So mostly lightweight structures are for tooling that's in motion more than an AGV. But the AGV advantage is that you can make a large AGV out of carbon fiber as a fixture, mobile fixture that matches the thermal expansion. So that's the big advantage is because you have something 110 foot long, the thermal expansion changes. It's, with steel and carbon fiber, it's a major problem.
Can your large-scale machines in agricultural adaptation be fully autonomous for tasks like picking corn or spraying fertilizer? Have you explored that at all?
Yes, well, there's all those systems are already out there. So they are doing automated picking of things. So all that technology is out there. So what the limitation is, if you're doing this stuff in a field, is that structure we showed in steel is just too heavy. It would sink in the ground, it would get stuck. It has all kinds of problems, having all that mass. So if you could reduce that mass by 10%, plus those long arms to get a high reach, if they're, a lightweight material that's high stiffness and quick dampening, that solves a lot of major problems with, something steel that it takes, the mass doesn't move instantly when you move something like that, and you need something lightweight, so you're reducing the mass is really important.
Got it. Can the electric liner be configured for different tube shapes, round, square, etc., so the extruded components can stay common?
Well, elastic liner. So the elastic liner, so we have a base clamp, and the base clamp accepts the outside shape of the liner, which can be an extruded material. And then when you change the liner, you clamp on different things. So you can have a clamp that clamps on English and metric diameter tubing. There's not a lot of difference. Sometimes, some are really close and some are bigger, so you can change that. But then you can also change the inside shape to clamp on like a hexagon or octagon tubing. So the Keogh has their tool builder system, I forgot what it's called, bodybuilder, with octagon tube. And they designed that to stop rotations. That's the major problem in clamping systems is rotation. And you have, they have the bolts that torque down to create a lot of force to stop slippage. So to stop slippage, the biggest solution to stop that is more surface area, more contact. And with these systems here, we can use less force, so there's less strain. And with the elastic liner, because it's flexible and the top cover comes off, so these clamps, they can just snap on any place. So you can pull the top cover off, and you pull the top cover off, the elastic liner is split on one side. You can put adhesive on half of it, which allows you to use peel force to break the bond. So you have no slip. And big advantage for that. Plus all the other advantages that the elastic liner has. So you can really have any shape you want on it and use the same body.
Got it. Thank you. Well, I think those are all the questions we've gotten in so far. So thank you, Jerry, and thanks to John and Greg for being with us today, and thank everyone for joining. Again, we are here on the third Thursday of each month, so stay tuned for the next liftoff webinar that will take place in October, and stay tuned to your emails for those invitations as they come out. Again, Jerry's contact information is on your screen, so please reach out to him if you have any questions or would like to follow up with him in any way. And then stay tuned to the LIFT website when this webinar gets posted, probably by early next week. Again, thank you very much for joining, and thank you for the presenters today. We'll talk to you next month.